Hello everyone, I'm Shravani from SVC Bangalore. In today's video, we will be introducing you to Raspberry Pi, its hardware layout, operating system, configuration to programming, and wireless monitoring temperature system. So what is Raspberry Pi? Raspberry Pi is the name of the credit card sized computer board developed by the Raspberry Pi Foundation based in the UK. It gets plugged in a TV or monitor and provides a fully functional computer capability. It is aimed at imparting knowledge about computing to even younger students at the cheapest possible price. Although it is aimed at teaching computing to kids, but can be used by everyone willing to learn programming, the basics of computing, and building different projects by utilizing its versatility. Raspberry Pi is developed by Raspberry Pi Foundation in the United Kingdom. The Raspberry Pi is a series of powerful small single board computers. Raspberry Pi is launched in 2012 and there have been several iterations and variations released since then. Various versions of Raspberry Pi have been out till date. All versions consist of a Broadcom system on a chip with an integrated ARM compatible CPU and on-chip graphics processing unit. The original device had a single core processor. Speed of device ranges from 700 MHz to 1.2 GHz and a memory range from 256 MB to 1 GB RAM. To store the operating system and programming, memory secure digital cards are used, which is the SD cards. Raspbian OS, which is a Linux operating system, is recommended OS by the Raspberry Pi Foundation. Some other third-party operating systems like the RISC OS Pi, Diet Pi, Kali Linux can also be run on Raspberry Pi. Coming to the hardware layout, essential hardware specifications of Raspberry Pi brought mainly include SD card containing Linux OS, US keyboard, monitor, power supply, and video cable. Optional hardware specifications include USB mouse, powered USB hub, internet connection. The Model A and B USB Wi-Fi adapter is used and internet connection to Model B is LAN cable. We'll talk about the different components of hardware. Coming to the memory, the Raspberry Pi model abroad is designed with 256 MB of SD RAM and Model B is designed with 51 MB. Raspberry Pi is a small size PC compared with other PCs. The normal PC's RAM memory is available in gigabytes, but in Raspberry Pi board, the RAM memory is available more than 256 MB or 512 MB. CPU. The central processing unit is the brain of the Raspberry Pi board and that is responsible for carrying out the instructions of the computer through logical and mathematical operations. The Raspberry Pi uses ARM1 series processor which has joined the ranks of the Samsung Galaxy phone. Display. The connection options of the Raspberry Pi board are two types such as the HDM1 and composite. Many LCD and HD TV monitors can be attached using a HDM1 male cable and with a low cost adapter. The versions of HDM1 are 1.3 and 1.4 are supported and 1.4 version cable is recommended. The OPs of the Raspberry Pi audio and video through HMD1 but does not support HDM1 by P. Older TVs can be connected using composite video. When using a composite video connection, audio is available from 3.5 mm jack socket and can be sent to your TV. To send audio to your TV, you need a cable which adjusts for 3.5 mm to double RCA connectors. Ethernet port. The Ethernet port of the Raspberry Pi is the main gateway for communicating with additional devices. The Raspberry Pi Ethernet port is used to plug your home router to access the internet. XP socket. The XP socket is used in Raspberry Pi board for the wireless communication purpose. Power source connector. The power source cable is a small switch which is placed on the side of the sheet. The main purpose of the power source connector is to enable an external power source, UART. The universal asynchronous receiver or transmitter is a series of input and output port that can be used to transfer the serial data in the form of text, and it is useful for converting the debugging code. GPU. The GPU is a specialized chip in the Raspberry Pi board, and that is designed to speed up the operation of image calculations. This board designed with a Broadcom Video Core 4 and it supports OpenGL. GPIO pins. The general purpose input and output pins are used in the Raspberry Pi to associate with the other electronic ports. These pins can accept input and output commands based on programming Raspberry Pi. The Raspberry Pi affords digital GPIO pins. These pins are used to connect other electronic components. For example, you can connect it to the temperature sensor to transmit digital data. Operating system. The Raspberry Pi OS is a unique Unix-like operating system based on the Debian Unix GNU distribution for the Raspberry Pi family of compact single-board computers. First developed independently in 2012, it has been produced as a primary operating system for these broad boards since 2013, distributed by the Raspberry Pi Foundation. Raspberry Pi OS is highly optimized for the Raspberry Pi with ARM CPUs. It runs on every Raspberry Pi except the Pico microcontroller. The Raspberry Pi OS uses a modified LXDE desktop environment with the OpenBox stacking window manager along with a unique theme. The default distribution is shipped with a copy of the computer algebra system, Wolfram Mathematica VLC, and a lightweight version of the Chromium web browser. The Raspbian Raspberry Pi OS, which could be possibly the Linux based OS for the Raspberry Pi, which is packed with necessary tools and compatible with most Raspberry Pi models, but not compatible with Raspberry Pico. Noops, that is the new out of the box software, can also be used, which is a OS installer on SD card, which specifies simplifies installation and included with new Raspberry Pi. While other operating systems that can be used are Minibium, which is the minimal Raspbian version, Raspbian Lite, which is the command line only version, RISC-OS, which is a unique non-Linux based, and Windows IoT Core, which is for Windows developers. Ubuntu Mate can also be used, which is for low power devices. And we have the FreeBSD, which is a Unix like runs on a low RAM. Laka, which is the lightweight gaming OS, and Open Elec, which is a minimal OS for media center. Then we have OSMC, which is an open source media center. Kodi based media management can be done. And then RaspBSD, which is a free BSD with OpenBox LXDE. Linutop, which is the Raspbian for digital signature. Kali Linux, which is for penetration testing OS. Dominix, which is for home automation system. OpenSUSE, which is for RPM based Linux for Raspberry Pi. RetroPie, which is for acting as an emulator for retro gaming, and Arc Linux ARM, which is a simple customizable Linux. Ubuntu Core, which is for minimal Ubuntu for IoT. Batocera Linux, which is a retro gaming OS. BMC 64 is just a Commodore 64 emulator, Gentoo Linux. It's a lightweight, adaptable, and we have the SARPI, which is the Slackware ARM, which is very simple and fast to boot. Okay, so the configuration to programming. A Raspberry Pi runs Linux and supports Python out of the box. Henceforth, you can run any Python program that runs on a normal computer. However, it is the general purpose input or output capability provided by the GPIO pins on the Raspberry Pi that makes it useful device for Internet of Things. Well, some simple Python programs on Raspberry Pi are we have print hello world, which is just the command print, having the text that is the hello world in the quoted form, and then a program to add two numbers. We have a and b as two variables, and we are adding them. So these are some of the simple Python programs that can be used on a Raspberry Pi, like just a few examples. And then we have a third example where we are printing Fibonacci series. Well, next is the wireless monitoring temperature systems. Wireless monitoring temperature systems in the realm of IoT represent a transformative solution revolutionizing various industries from healthcare to food logistics. These systems utilize sensor technologies to continuously measure and transmit temperature data wirelessly, enabling real time monitoring and analysis. By leveraging IoT connectivity, they provide unprecedented levels of accessibility and flexibility, allowing users to remotely monitor temperature conditions from anywhere at any time. Such systems not only secure complaints with regularity standards but also enhance operational efficiency for proactively detecting and mitigating temperature fluctuations or anomalies. Furthermore, the integration of advanced analytics and machine learning algorithms enables predictive maintenance and optimization of temperature control environments, minimizing risks and maximizing productivity. As the demand for precision and reliability in temperature monitoring continues to grow, wireless monitoring temperature systems powered by IoT are poised to play a vital role in shaping the future of industries reliant on temperature sensitive processes. Thank you.